Hello, everyone, and welcome to our session, Building Real-Time Machine Learning Pipelines with a Feature Store. This talk is presented by our guest speaker, Gilad Shaham. He has more than 15 years of experience in product management and research roles at cutting-edge software companies. Gilad studied a Master of Science degree as well as an MBA at Tel Aviv University, and he's currently the Director of Product Management at Iguazio. Today, he will be speaking about the challenges around building a feature store for machine learning pipelines that deal with real-time applications. So with further ado, Gilam, please take it away.
All right, thank you, Juan. Hi, everyone. Good morning. Thank you for joining. And let's jump in right to the discussion. We're going to talk about the challenges for real-time ML with Feature Store. And one of the things that we need to take into account is that the challenge of handling real-time data is across different verticals, different industries, whether it's financial, retail, telecommunication, or anything that does predictive maintenance, manufacturing, autonomous vehicles, or any scheduling. There are a lot of real-time requirements around the world where AI needs to respond very, very quickly. And if you try to look at how to address this, there are problems that cannot really be solved using batch processing. So we all know that training models is usually done in batch, but when you actually get to the production environment, you need to be able to respond in real time. So, for example, if you need to quickly replace any device that you have and check the data from the last 30 minutes, then you need to get that data immediately, and you cannot really wait another day or two because you would lose business. The other thing is if you want to do real-time recommendations, for example, if someone has been viewing specific articles and they want to see the next one, or if we're talking about a retail example, if they're in a store and you want to suggest to them to buy something, you need to do it right now. We've all been ordering more food at home, and we expect it to arrive within, let's say, 30 minutes. So again, we need to process real-time data of traffic data, of orders, and make sure that this arrives as expected. And something that is also I have past experience with is for fraud prediction. If you need to detect fraud and prevent fraud, this has to be in real time. Transactions, financial transactions occur all the time. You have trillions of transactions going in, and you really have to, you have very small amount of time, sometimes it's even a few milliseconds to decide if this is a fraudulent transaction, whether you want to stop it. So that's another key challenge here. And when thinking about why it's so difficult to address these issues is if you think about how data scientists work. So data scientists are not data engineers. And when they access the data, they usually access some batch data. It could be a Parquet file. It could be that they access some database, but they don't know or don't even want to be involved with how to deploy things to production, especially when dealing with technologies for streaming, such as Kafka and things like that. So often you would find that some companies just say, okay, let's rewrite it. And this is bad because, one, it will take a long time, and two, how do you make sure that the same feature that you defined here in the batch will be the same as the streaming one? So rewrite code is really, really bad from that point of view. And again, think about MLOps. This is something that significantly increases the time that it takes to get to production. Another thing is to think about the performance. So you need to make sure that your real-time calculation are performant and done at scale. Again, going back to the data scientist and the work, we don't want to overburden data scientists with thinking about the technology and how to optimize things. We want things to work seamlessly and in real-time, low latency, and not have to deal with all those technical issues. And also think about transformations. So a lot of time, the examples that I previously gave require thinking of a sliding window. Give me the data from the last 30 minutes, from the last 1 hour, for the last 1 day. This is really difficult to do in SQL language. So if you have a data engineer that gives you some SQL query to do that, in real time that won't work. You need something that works at a sliding window. Enrichment is another example. Sometimes you want to look at a set of information or enrich from the person's history or from the device history. So you need to quickly query that data and do that continuously. I mentioned the consistency between training and serving, and again, it goes back to being able to write the features once. Another important aspect is also being able to identify drift on the feature level. If you have data coming in real time, how do you identify if the data has been changing? If this is a discrete one, maybe it's a category that is different, maybe it's a continuous one. How do you evaluate that the average standard deviation fits the data that you expect to have in your training environment? Another key aspect, it's not just for real time, is reusing features. Often we see that in organizations that have many models, the same features are being used in different models that are very indicative. So we need something that helps the data scientists reuse features rather quickly and not have to reinvent the wheel every time. And finally, feature versioning, it's also very important. If I'm changing the feature definition, first, I need my previous model to continue working. And two, I need a way to monitor and understand if I change something over time. So far we talked about the main problems here. Also need to consider that we're not just thinking about the real-time scenarios, although this talk is more about real-time machine learning. Think about the overall operationalizing machine learning. We're talking about, this is an MLOps discussion overall. So think about not just the real-time, but a broader perspective that you have data engineers, DevOps engineers, and data scientists that need to work together. There's a lengthy process that if you have to rewrite your features and work in every time that you need a feature, ask a data engineer to do that. It's a very lengthy process just to get to production. And having a quick access to those features really reduces that time. Furthermore, if you want to improve your model accuracy, it's not just monitoring the model itself, but also monitoring the feature and understanding the root cause for why models have reduced accuracy over time. And this is something that you want the features themselves. So we want to talk about the feature store and how this solves this. So, and this slide shows how all these problems can be solved using the feature store itself. So one thing to remember is that the feature store is very important from the operational pipeline process. So data is coming in, it could be operational data, it could be real-time data coming in from different sensors, or streaming data coming in. And the feature store itself allows us to do those transformations in real time based on the data and serve those models in real time and do that without rewriting that code. From the user's point of view, they have access to those features. It could be the data engineer who could define the features, the base features, and the data scientists themselves can write features on their own in a very simple language that would later be translated to those real-time transformations. They can also get features if they want to train the models and create some batch processing in their notebooks, and later on just say, okay, I want these features to be used for that model. So that feature store would also serve them during those training environments. And from the MLOps engineer point of view, the feature store really reduces the whole deployment of those models and those features. Think about, again, model deployment is not just about the model, it's the entire data pipeline. So they are able to fully understand how to deploy things because everything is managed and a feature is a first-class citizen in your deployment environment. Another thing important to emphasize here is the model monitoring, which again goes back to you don't want to monitor just the features themselves, just the model itself, or you also want to monitor the features to understand those root cause. So you want something that works seamlessly and in a what we call a glueless integration for all of that. And once you understand the model that you have some kind of drift, you want the ability to retrain from the production data. So you want, again, to be able to get that data back, those features back, to either the data scientist or to an automatic process, CI/CD process that allows you to automatically retrain your models based on the new features. Now, one thing to consider is that when you first hear about feature stores, I don't know how many here are familiar with that. It sounds, okay, this is too good to be true. But think about, when you first heard about how to do machine learning or deep learning. It also sounded like magic until you just learn how it works. So behind the scenes, it's from the software point of view, it is a bit complicated, but the idea of the underlying principle is not that complicated. The general idea is that the data scientists or data engineers, all they have to do is write their logic in transformation and validation logic in a high-level language, which the feature store, we can convert it automatically to high-performance serverless engines that can be used for scale, that's to solve the scale problem immediately, and where we can use that in order to transform data, whether it's in batch or in real time. The real secret sauce, I would say, for the feature store is the ability to store data in an online storage, which will later be used in the production data. So once you have this transformation capability that can run both in batch and in real time, and you have this online storage that is very, very fast, in the model serving, all you have to do is fetch that data and update the data in real time. But this is really the data, the fast data that is doing the heavy lifting in there. The feature store is really utilizing it and creating those transformations on top of that data there. And and the fact that it's smart enough to understand how to do the transformations using those type of data storage. But that's really the way that it works behind the scenes. Without the feature store, of course, you can do it, but then you have to access those data storage, these online data storage and offline data storage, and translate your transformations to that online store, which is doable, but it's a lot more work. The feature store pretty much automates that process for you. And if you look at how this looks in practice, this is our implementation of a feature store. The data scientist or data engineer, in this case, it's even a data scientist, simply write what would be their transformation logic. They define here a data extractor and the map values, do one-hot encoding and aggregations in various time frames and various type of aggregations. And this translates into a list of transformations that the feature store can do and store this data in an online storage and an offline storage as well. But from the data scientist's point of view, it's really a very easy to use language to describe those transformations. We also mentioned monitoring. So again, you need something that allows to detect drift, not just on the model level, but also on the feature level itself. So, for example, if we know that I'm expecting a specific average and this starts to drift, I can understand that the feature has drifted. Maybe the model has drifted, maybe has not, but this gives you more insight on what is happening. And the fact that there is a feature store that is not just standing on its own, but also is part of this monitoring capability, the serving capability, and the training, we can also trigger automatic retraining. So the data scientist can create just a pipeline, and if some kind of drift happens, if they want to automatically retrain, they can do that. Or they can view what's happening and create a new model. That's fine as well, but it really reduces the time to understand what's happening in practice in production. Now, until now, I talked, okay, this is a feature store and this is great, but let's try to also see what have we done with it in practice. So we have a few examples of actual customers that have used our technology. And the first example that we give here is Samsung, specifically Samsung Card, which their use case is that they want to give recommendations. So when you go to a store, you're able to get a recommendation that in this store you should buy something. The main thing is that one of the main requirements, and so it can be beyond just being real-time, of course, is that they wanted to have very high accuracy or very low false positives. 95% conversion rate is the target, which is very, very high, which requires them to be able to process a lot of data and figure out in real time if it makes sense to give a person a recommendation to purchase something or not. And because a person is based on the location, they have to do it rather quickly. And with a feature store, we're able to do that for them to define those features very easily. And because it's very, very scalable, they're able to do that in very high scale and low latency. A different example is identifying fraud. So we worked with Payoneer, Payoneer manages money transfer between different territories, and they work across 200 different countries and territories. So they have a very big challenge of identifying this fraud. And one of the main things that we have done, again, using this technology, is move from a batch behavior where where the detection was in about half an hour, give or take, to very few seconds. And the fact that, again, using the feature store gives them the ability to define features and even more complex features in real time. Last example that I'll give here is NetApp. So NetApp are using, they have the ability to do predictive maintenance. Obviously, they have a lot of different storage devices out there, and they want to be able to monitor what's happening and detect that before there is a failure in the device, and even trigger a maintenance event and send a new storage device to the customer. So before we started, it was really a batch process, and there was a lot more code that was required in order to actually deploy or do that logic. And because, if you remember, the feature store allows us to define a very easy to use language, a high-level language, it reduces the amount of code, it reduces the amount of time to develop things. And overall, because we also take care of the scalability, everything was also, they even had to reduce, they were even able to reduce the amount of hardware that they needed to do in order to process all these events. And obviously, because they keep going, this keeps going and going, and the system scales up very, very nicely. So this is a relatively short session, so we don't have a lot of time for a demo, but I will show you just a quick view on how this environment would look like. So this is our example for doing a fraud detection. And we have transactions that are coming in and events, for example, password change or someone logged in. And each one of these is what we call a feature set. A feature set is a set of features, obviously, where there are various aggregations. So let's have an average amount in the last 12 hours or 2 hours. And all these features are generated using this transformation that we have seen earlier, and create all those aggregations. So it's not just an aggregation, it's the pre-processing that you're doing to the data itself. Of course, when you look at those features themselves, you can see some statistics and understand what's going on, and also see some histograms on the data and understand what's going on in there. This goes back again to the ability to share features between different users. And again, that to show that this is the actual code that was used in order to generate this feature set. And the nice thing about it is that we have created an engine here that allows you to ingest data, not just in batch and process it, but because it's a very powerful engine, you can also do that in memory. So let's say I'm looking in the fraud example, I'm looking at people, I'm looking at the actual transactions, and I want to ingest the data and do transformation and make sure that the transformation makes sense. So what we do here is actually run this pipeline in the notebook itself, and we're able to figure out if this makes sense or not, and the user can change the pipeline before actually even saving any data to the storage themselves, before actually committing something inside the feature store, which is much more powerful than using, storing it to some kind of SQL database or doing like that. This is the actual transformation. And the other important thing here is that I don't need to rewrite it. What I wrote here is exactly the transformation that I would use for the deployment. And the way that this is done is we create a feature vector from those features. So in the training process, the data scientist will define the feature vector, which could be a combination of different feature sets, for example, combine the transactions and the events. Again, you can see statistics on the feature vector level. The code does some feature selection, and then they select the specific features. But at the end, the question is how to operationalize this. So the way that it works here is that the data scientists can just define the model that they deploy, and they define the feature vector that they want to use in the deployment itself. In this case, we also show that we can do an ensemble and so forth. But the important thing here is that they just use the same feature vector that we use in the training itself, and that feature vector would be calculated in an online manner whenever there is a new transaction. We enrich that transaction using that feature vector and send it to the model with all those transformations. So really what we have seen here is that events are coming in to the development pipeline as well as the production pipeline. We ingest the data, we can ingest the data to the feature store itself. In the training, we get offline features to the training. When we deploy those models to a serving pipeline, which can get the data in an online manner. By the way, I didn't mention that when we show the code, but we also update, of course, the features in real time, because think of a sliding window that needs to update in real time. So that's important for us to constantly update the data. And at the end, there's model monitoring. So we need to monitor the model, and we need to monitor those features. And once we detect the drift, we have an automatic process that allows us to retrain models if, for example, a feature has drifted or something has changed. So this is all facilitated by the fact that we know those features exist and their properties. That's pretty much the topic. If there are any questions,
okay,
I would gladly answer.
Very much, Gilad. That was such an interesting talk. Thank you very much. I really enjoyed the diagrams, the figures. So we have some questions from the audience. Let's go with first from Mahavir. Does feature store make sense if there is not too much reuse of features and none of the models are not many? Some of those models are useful by real-time APIs. Okay, that's a bit confusing. Okay, yeah, I guess the question is, does feature store make sense if there is not too much reuse of features?
Yeah, so I think that the question for feature stores, especially regarding this discussion, is that reuse features is just another benefit, I would say, of a feature store. The main thing is if you have a batch process for training and an online process for serving, and you have those features transformations that needs to be done, that's where the feature store's main benefit comes. So even if you have different models, but that don't use the same features, but you would like to have an easier way to deploy your models and the data pipeline, then that's the real power of the features of the feature store. The reusability is a nice property, and by the way, over time you might discover that you are reusing those features, but I don't think that's the main drive force. If let's say your serving is only batch, maybe you won't benefit that much from a feature store. I think that's the main distinction.
Okay, thank you. Sounds good. Now the following question from Gian Mario. How do you store the feature when it's a pre-processed image?
Um,
Yeah, so
but you saw the
features are no longer like characters or numbers, strings, but a
okay.
binary file, I guess, an image.
So thinking about deep learning and not machine learning, is that the?
Uh, I don't think this is necessarily about deep learning. Maybe just like data that it's not like easy to parse. It's not alphanumerical. It's an image. Is that possible to be stored as a feature?
Yeah, so generally, the data doesn't have to be necessarily, just string or number. There are various types of data, if that's the question. So I would say there are two parts here. So one, you have different data types, and if the question is, if you have, we also store it in binary form. For example, we store it in Parquet for the batch processing. That's one thing. If the question is not just it's about unstructured data or things like that, we also have examples for that. So, for example, if you want to process an NLP pipeline and you want to use the feature store, this is something that we also have here. Or if you want to pre-process an image, if the question is about an actual image or a video or something like this, and you want to do some transformations on that, the feature store can also serve on that. Classically, it's usually for numeric data or string data, but we do have examples of using feature stores for these scenarios as well.
Thank you. Yes, I see some follow-up comments from Gian Mario. He's essentially referring to storing data in the form of tensors.
Yeah, so that goes back again to using Keras or TensorFlow and doing the pre-processing. For example, if you have a significant pre-processing pipeline, let's say it's a CT image of a lung, and it's a three-dimensional, and usually do a lot of pre-processing before that because it's too big for a model. There isn't enough data for a neural network model to actually process everything. So usually that's a very significant use case to do that. Or again, if using NLP, if you have text and you want to extract information before actually sending it to your models, or using the model itself as a feature, that's another example. That's certainly something that we're seeing out there.
It looks like we still have time for like one more question, like really quickly from another attendee, from Joel. Is the conversion of a feature to real-time compatibility through the feature store only a matter of storing the feature output using a fast read storage technology? Or does it ever support situations where the original source of the data needs to change to support real-time calculation?
So I think it depends. So if you do have the feature store kind of changes the boundaries, I would say, for the data processing. So classically, the way that data engineers would address it is that they say, okay, now I create some kind of streaming or real-time process of that same data and re-implement that feature. So a feature store, it takes away that part. It doesn't take away everything. So if your data is just batch and you get data once a day, obviously your actual online processing would be dependent on that. But if you do have some kind of streaming, Kafka, or any kind of real-time or sensors coming in HTTP or whatever, the feature store allows you to do those transformations much more easily than before, because you don't have to rewrite those transformations. So I think the question is, we still obviously depend on some kind of source that's coming in in real time or streaming, because we want real-time transformations. But the feature store makes it much easier to do those later processing beyond the raw data.
Okay, thank you very much, Gilad. Looks like we're running out of time. Thank you very much for your time. Thank you to the attendees for joining. I guess they can reach out on LinkedIn maybe, or in case they have further questions, or they can try to contact Iguazio directly.
Certainly.
I guess at this point, I would like to ask the audience to join me with a virtual applause for Gilad. Thank you very much for the talk. There is an applause icon, yeah, in the chat. Thank you very much. I really enjoyed the talk. Hope
Thank
to
you all
see
for your
again
time.
in other
Appreciate it.
talks. Bye.
Thank you. Bye-bye.